Number 7. In the following problem, you are going to investigate two different function transformations. In part A, a function is defined symbolically. In part B, you will use the graph of a different function. Okay, list the function transformation steps in the correct order for building the function g of x equals 2 over 1 plus x minus 3 from the parent function 1 over x. An example is provided at the bottom of the page. So just for reference, down at the bottom of the page, if you want another example, there is one there. I will let you look at that on your own though. So here we go. We're going to take the parent function 1 over x, and let's kind of write out the steps. What we're going to do first is actually let's make the appropriate list is the following. We do horizontal translations first. Then we do horizontal and vertical stretches and shrinks. One, two. Then we do reflections. And then we do vertical translations. Okay, so that's the order of events here. So keep that in mind as we're doing this. So the first thing that I'm going to do is look to see if I have a horizontal translation, and I do actually. So because if I want to go from 1 over x, I need to go to, that denominator needs to be x, that's like x plus 1. So I need to go from this to this. Okay, and that's the same thing as if this is g of x, this will be g of x plus 1. Okay, and that's going to be a shift. We can write out what we're actually doing here. This will be a shift left one unit. Okay, and what's our next step? So do we have horizontal or vertical stretches or shrinks? Yes, we do. We have a vertical stretch. By the way, so you know what, I called this G, that was actually P, because P is 1 over x, so sorry about that. That's P of x, then P of x plus 1, and then we're going to do 2, oops, we do this up here. So 2 over 1 over x plus 1, right? And that corresponds to 2p, I'll write it like this, arrow 2p x plus 1. So that is a vertical stretch by a factor of 2. Okay. And then finally, we don't have a reflection, but we do have a vertical translation, which will be down 3. And so then we're going to say 2p of x plus 1 minus 3. That is a shift down 3 units. And so that would take us finally to 2 times 1 over x plus 1 minus 3. And that's the final product, g of x. So the actual final version would be g of x equals 2p x plus 1 minus 3, like that. And then I've got my actual graph changes written beneath there. Okay, cool. So let's move on to part B, which says, consider the graph below. The function h can be written in terms of f is h of x equals a times f cx plus d plus b. Determine the values of a, b, c, and d. So that's sort of a scary looking question, but the basic idea is how do we take the upper function and turn it into the lower function? So the upper, this one, and turn it into this one, okay? So just try to imagine, how you would do this visually. So, and we'll have to kind of check ourselves as we go, but it looks to me like essentially what I want to do is stretch this horizontally and then slide it down. Okay. Now you might say, well, how do you know that that's the correct things to do? Well, I'm not saying 100% that that's it, but that's just my initial intuition. And to justify that, like, why don't I think that this has a vertical stretch? Well, let's look at the actual picture. Like the vertical, this has a name, it's the amplitude, but the amplitude or the vertical kind of distance covered by the function here is 2 units. And do you see that that same vertical distance from trough to crest of this function is still 2 units? So no vertical stretching or shrinking is necessary. Okay, so that's why I say I don't think I need any kind of vertical stretching or shrinking. I also think that I don't need to have any kind of horizontal shift, any movement left or right. Now, I think I need a stretch left or right, but not a slide. And the reason for that is because I think that I can accomplish the lengthening of this picture without having to slide it around. And so let's see how we can do that. And as far as the reflection issue goes, well, I'm just comparing visually, if I reflected this over one axis, it would look something like that, which is not really what we have. And if I reflected it this way, it would be something like that, and we don't have anything over there, so it doesn't look like reflections are going to come into this either. So, I'm just kind of feeling this out, but now let's get more specific. So, stretch horizontally. So let's talk about that. How do I determine the horizontal stretch? So there's a couple of things we could kind of do to wrap your head around this, but one thing is just to kind of follow some points around. So for example, this point here is -5, 3. And I hope you agree that this is the point kind of that it looks like it should correspond to. And this point has coordinates -10, -2, but I'm more concerned just with the x coordinate. So we went from -5 to -10, so that doubled. And let's check. So it seems like maybe it's doubling. So let's look at a few more. So what about this crest? So that's -3, and it's 5. And where does it go? So -3, and so the crest is here. Now it's at -6, 0. And so that's 2 of these points that have their x values are doubling. Let's check one more. What about this one? So this one is at 1, 5, and it now is at 2, 0. And again, the x coordinate is doubled. So I feel comfortable saying if we stretch this by a factor of 2, then we will be moving in the right direction. Okay, so if we want to stretch by a factor of 2 horizontally, remember that actually means that we multiply the input by 1/2. So that's going to look like f of 1/2 of x. That would be stretching it by a factor of 2. Okay. And so that would get me, I know my picture is pretty messy right now, but that would take, let's kind of sketch this briefly. That would take my original graph, which looked like that, and it would basically stretch it out so that it looks, more like, I'm doing a terrible job of drawing this, but it would look more like that. It'd be on the same height though. And now what we want to do is just move that down. And so how much do we need to move it down? Well, we can just follow some points again. So where is this crest going? Well, right now it's at 5, and then here it's going at 0. Now this one went from 3, and now it's down here at -2. So it looks like we're moving down 5 units. So let's try f of 1/2 x minus 5. Okay, and so that's going to get us this function transformation. And to actually answer the question, what's A, B, C, and D? So let's go back and check that out. So A is 1. B is -5. C is 1/2. And D is 0. Okay. So we can do a little bit more here just to give you some more background on this problem. What if we could check our corresponding points? If you want to do this to see, how we did. If I take, say, the point right here, -5, 3, on the original, then under this transformation, under the new graph, -5 gets, the only thing that happens to the -5 is it gets actually doubled by this input of 1/2, because remember what the whatever is happening, whatever number that is, it's the reciprocal that actually happens for the x coordinate, so that's -10. And what happens to the y coordinate? Well, 3, so this is the y coordinate, we just subtract 5, so we have 3 minus 5 is -2. So now we just need to check, is -10, -2 actually on the graph? So yes, it is. -10, -2 is that point. So that point went where it was supposed to go. And we could check another one. Let's say, how about 1, 5? So where does 1, 5 go? Well, 1 should get multiplied by 2, and 5 should get 5 subtracted from it. So 2, 0 should be on the graph, and indeed it is, 2, 0. So you can check your corresponding points and make sure you're kind of on the right track this way. You could actually even kind of do this in the reverse order and start with what you wanted your corresponding points to be, and then develop the function from that. So you could say, well, I want -5, 3 to go to the point -10, -2, and then figure out what your corresponding x and y transformations have to be in order to accomplish that. So in order to get -5 to go to -10, we're going to you sort of work backwards, right? You say, well, 1/2 of 10 equals 5, and then you solve for your original value. Okay, but anyways, that is what number is this? Number 7. Okay.